Okay. Today and tomorrow, Tuesday, Wednesday, we're going to look at more on the graphs of piecewise functions. When I graph a piecewise function, its graph is what's called a step function. A step function, by definition, is a graph or function that increases or decreases abruptly, sharply, from one constant value to the other. Here's a step function. To me, it kind of looks like a staircase with different steps on it. Here's one step, here's the next, here's the other. I change from step to step to step pretty quickly throughout the graph. They're not connected, it's not one smooth curve. It changes dramatically from one constant value here to here without much movement left or right. It changes pretty abruptly as I move throughout the graph from left to right. Our goal is to take the graph of a piecewise function, to take this step function, and find the value of these points below. Just like I had you plug in some numbers given an equation of a piecewise function, now you're going to take the graph of a piecewise function and use it to find the value of the function at several different points. Does that make sense? So my step function is broken up into 3 different pieces. Let's think about what values of x work for each of these different steps. We're going to count right and left along the x-axis. To get to this point, how much to the left did you count? From one tick mark to the next? 1, 2, 3, 4, 5 to the left. This x-coordinate at the left endpoint of this first step has an x value of -5. Is that reasonable? How about the right endpoint here with this open dot? How much to the left did we count now? -3. Sometimes you're going to have an open circle. Sometimes you're going to have a closed circle. The value of the function is closed in here. The graph actually exists at this point because it's a closed circle. It's included when it's a closed circle. For an open circle, it's excluded. The graph doesn't exist there because I didn't fill it in. So this step is for x values that are between -5, including the -5, and -3, not including the -3. All values of x that we're trying to plug in from over here, if it's between -3 and -5, I'll use this step. Why did I put the equal to on -5 here for its inequality, and not the -3 for the right endpoint?
Closed circle.
Closed circle, open circle, right? Is that what you're going to say, so?
I said it was including negative.
The graph exists here because of the point that's been filled in, but not here. If I'm trying to plug in -3, I got to look elsewhere on the graph. I got to look at a different step, which leads me to here. Let's figure out where this left endpoint and right endpoint are at for the next step. Since I left off with -3 here, for the next endpoint, I bet it starts at -3. How about the right endpoints? How much left to right did I count to land on this top point here? 0. So for all x values, from -3 to 0, I'm going to use this step to evaluate the function. They're both closed dots, so they're both included. I'm going to need equal to for both of them. For all x values from 0 to -3, including both 0 and -3, we'll use the top step in the graph to find our answer and a value. Now this step on the far right. Since this step left off with the right endpoint of 0, the left endpoint of the next step also starts at 0. How far to the right do I count to find this endpoint for its right side? Count 1, 2, 3, 4, 5 again? But they're both open circles. Are those actually parts of the graph when I leave them open? No, I didn't fill it in. There's not actually a graph there. I left them open. They're excluded. So for all values between 0 and 5, not including the two endpoints 0 and 5 themselves, I'll use that par step on there. Let's actually do it. what's the value on the graph of function f at x equals -5? That's what this notation means. What's the value of the graph? What's the value of the function at x equals -5? Where does -5 fall in? This inequality, this middle inequality, or this inequality on the left? Where's the left one, right? Isn't -5 between -5 and -3? Would I include the -5 here too? Okay. So we're going to look on this step. What value does this step have? If I go left 5 for my x coordinate of -5, how far down do I count to land on the graph?
2.
Where is the graph at? Where x coordinate is -5. You just said go down 2, so that means our answer is -2. Let's try -3.01. Where is 3.01 at with these three inequalities again? First one again, right? -3.01 is to the left of -3. It's a little bit less than -3. It's not between 0 and -3, between -3 and -5. So if I count left, 1, 2, 3, and then just a little bit more, I can't go up to find the point because it doesn't go that far to the left. I have to go down and land on the graph here, right? So it's still -2. This -3 trips people up. When x equals -3, if I count 3 to the left, which point do I pick? The one below or the one above? Why are you saying so? Or why are you saying the top one, Sophia?
Because it's excluded on the bottom and the top.
The graph doesn't exist for this open point. The graph does exist for the top point, right? So now I switch steps, right? The reason not a part of this inequality, but it is a part of this inequality. So how much do I count to go up to find the graph here? 4. That's where it changes from one constant to the other. That's where the graph is broken into a different piece or a different step. Okay, 0. Sophia's saying that when we're trying to find the value of f of 0 when x equals 0, which point do you pick? What do you say, Tori? Is it at 4 or 1? When x equals 0, do I pick the open circle at 1 or the closed circle at 4? 4. Reason behind that is, does the graph actually exist at the point that's not filled in? No, it exists when the point is closed in. Makes sense to me. 0.01. Where would 0.01 be at? That would just be to the right from the origin. I'm not going to pick this top step because positive 0.01 is not between -3 and 0. It is between 0 and 5. This top step doesn't come out enough when I try and put 0.01 right here, just to the right of it. What point do I need to pick? What step did I pass through on my way to the top? Looks like at 1, yeah? Caleb, what do you notice about 5? This is also kind of tricky. If I go over 5, what point do I find? This open circle, don't I? Does the graph actually exist here, Caleb? No. Is 5 included in this inequality? Is 5 less than 5? No. It does not exist. It is no solution. The answer is that there is no answer.
We say undefined.
We're going to say undefined. You bet. We're going to describe that as undefined. We don't know what happens here. It's not been filled in. There is no value of the graph. It's simply just undefined. Could you guys try what's over here with the next graph in red? Get a little bit closer.
Yeah. Is there going to be an instance where the lines are overlapping one another?
Could be. The lines could connect, the lines could overlap.